Welcome back to Science Modernizers. In this video, we are going to see dimensional analysis, a particular question on dimensional analysis, that is June 2022 physics question 1. The question reads that the energy generated per unit time by a wind turbine is given by the equation E is equal to a half or a kV cube n, where rho is the density, is the air density, A is the area swept by the blade, V is the wind velocity, and K is the coefficient of performance, and V is the generator's efficiency. The first question says we should explain with the help of an example why homogeneity of a physical equation is not a sufficient condition for the correctness of an equation, and the B says we should determine the base unit of constant K. So let's get started. The equation given to us is E equal to a half or AV squared. Notice that this E which was given to us is not energy, but it is the energy per unit time. So we need to be very careful with this statement, because if you use this as energy, then definitely you are going to have an equation in such a an equation which is not going to be homogeneous actually, because this expression already is an expression for power. So if you use E as energy, then this expression which you see here will not be homogeneous. So E is the energy per unit time, so we need to be very careful with this statement. So with that said, the homogeneity of a physical equation is not a sufficient condition for the correctness of an equation due to the presence or absence of a dimensionless constant. That is, an equation can be dimensionally correct but physically wrong. So how can we explain this? Let's take a good example. Let's take Newton's second law of motion, which states that the rate of change of momentum is directly proportional to the applied force and takes place in the direction of the force. From there, Newton had to deduce that F is equal to ma. Now, F being equal to ma, this is the statement of Newton's second law. F is equal to ma, but F is equal to 5 ma is homogeneous. This equation is homogeneous, but 5 is a dimensionless constant, which makes this equation physically wrong. So this is an example of the fact that an equation can be dimensionally correct but physically wrong due to the presence of this 5, because the constant of proportionality when we solve Newton's second law is actually deduced from the definition of a Newton, that is from F is equal to kma. A Newton is simply the force required to move a body of mass 1 kilogram by an acceleration of 1 meters per second squared. So with that definition, we can have the constant of proportionality from the statement of Newton's law, and that constant of proportionality is equal to 1. There are several cases which we can use. We can also use the period of oscillation of a simple pendulum, where t is equal to 2 pi the square root of L on g, and if you remove the constant 2 pi, then that equation will not be physically correct again. Okay, so the next part says let's find the base unit of K. So from E, the energy per unit time is equal to base. If we make K the subject of the formula, we will have that K will be equal to 2 times E divided by N raw AV cube, where E is the energy per unit time. I still insist on this. So the units of E is the unit of energy divided by time. So therefore it means in the units of energy, we can get it from force times distance, which is the kilogram meter squared seconds to the minus 2, divided by the units of time, which is the seconds. And simplifying this, we get the kilogram meter squared seconds to the minus 3. So from there we deduce the units of density. We know that density is the mass per unit volume of a substance, so it is actually the kilogram per meter cube. Units of area is the meter squared, and the units of velocity or speed is given as the meters per second. So from here we can deduce the units of v cube. So v cube means we just raise this equation to the third power, where we are going to have v cube to be equal to the meters cube second to the minus 3. So therefore the base unit of k will be 2 times the base unit of E, which was the energy per unit time, divided by the units of density, the units of area, and the units of velocity cube. But since we know that 2 all over n is dimensionless, that's why they were not included here, so they have unit 1. So if we simplify this expression, we are going to have the kilogram will cancel with the kilogram. This meters per meters cube will cancel with this meters cube. This meter squared will cancel with this meter squared, and the seconds per seconds cube will cancel with the per seconds cube, where we are going to deduce that the base unit of k is equal to 1, telling us that it is a constant. So this equation generally is an equation which is seen in energy resources. So with that said, that is what was required of you in this particular year. So thanks for watching. Please like, share and subscribe. Stay blessed and see you in the next video.